Hello everyone, welcome to the BOOKphilic YouTube channel. Now in this video we are going to understand the rules of grammar. Okay, so in compiler design, just like in English language, we want to speak in Hindi and translate it into English. So in order to translate it into English, the language Hindi, we need some rules. And that rules, the collection of rules is known as the grammar. So in order to make the perfect meaningful sentence in English, we need our rules of grammar. So in that way, whenever we want to convert one high level language into low level language, we need our rules of grammar. So in that way we are now understanding the rules of grammar, or you can say simply the grammar. Okay, and now in compiler design we may define the grammar as four tuples: the VPTS, VPTS, or you can say where V is the variable or non-terminal, T is the terminal, and P is the production rule, and S is the start symbol. Now you want to ask that what do you mean by variable, terminal, production rule, start symbol? So let us make you understand by a simple example that suppose I am writing one rule of grammar: S derives, and this arrowhead symbol is known as derives, and S is nothing but the start symbol that is written over here. S such that start symbol. Okay, S derives A B C, and then we are writing slash, or you can say or symbol, A B C or capital A, and in the next line capital A is deriving nothing but the small c. Okay, now what do you mean by this variable, terminal, production rule, and start symbol? So let us understand it. Okay, so first of all you have to understand that this S derives A B C or capital A, and capital A derives small c. This collection of rules is nothing but the production rule that we have written over here and nothing else. So now uh, let us understand one more thing before going to the next part. Now can you able to see this small a, small b, small c? If yes, then no worry about this. This is nothing but the terminals. So you can say that the small letters of alphabet is nothing but a terminal. But what we can say this one, capital A, so it is nothing but the variable. So variable or non-terminal is nothing but the capital A written over here, and this is small c is nothing but the terminal. Now you can also say that a terminal, you are understanding or not whether this A can be further derived or not. Yes, we can write A instead of C, or we can write C instead of A. Okay, we will be taking one example later on. For the time being, now you must understand that the capital A, small a, capital B, small c, capital D, small d, these are the types, or these are the alphabets we are going to use in our production rule. And wherever you will find the capital alphabets such that capital A, capital S, capital M, capital R, so these are nothing but the variables, or you can say non-terminals. But in case of small a, small b, small c up to z, these are nothing but the terminals which cannot be derived further on. And what do you mean by start symbol? Start symbol is this symbol which is starting from S. So basically the root node of the tree will be capital S. So this is known as start symbol, and this whole rule is known as production rule. So I hope you have understood these four terminology: V, P, T, S. That is V for variable, P for production rule, T for terminals, and S for start symbol. Now you have understood, and you can define the grammar as four tuples where V, T, P, S is nothing but variable, production rule, terminal, and start symbol respectively. So let us move on to the next things, that is non-terminal, terminal, production rule, start symbol. These are nothing but a small sentence in order to define the terminology of these four name, that is non-terminal, terminal, production rule, and start symbol. So first of all, let us understand this non-terminal. So non-terminal is nothing but the internal nodes of the parse tree which can be divided or derived further. So as I have told you that in the previous example, as you can see it over here, that the capital A can be derived further on in small c. So that's why the capital A is known as non-terminal or variable, and this capital S is also known as non-terminal, because this capital S either can be derived into ABC, that is a small abc, or either can be derived into capital A. That's why it is also known as non-terminal. And what is terminal? So let us say take one example again. Okay, before that, let us read one more thing. Leaf nodes of the parse tree which cannot be divided or divided further, means in the previous example where we have taken these things, that capital A derives small c. I hope you can see it. Capital A derives small c. Let us erase first of all these things. These are the messy things, so that you can understand properly. And these are the shortest notes that I can write or type, and you can also note it over your notes in order to make yourself understand. Okay, in this case, now you can see it here that we are taking small c and capital small a b c. Can you imagine whether there is in the left hand side of the production rule, is there any small abc? The answer is no, because the small abc cannot be derived further on. That's why it is known as terminals, whereas capital A and capital S can be seen in the left hand side of the production rule. That's why this can be derived further on. That's why it is known as non-terminals. So I hope you have understood. And the production rule is nothing but the rules to derive non-terminals. So these are the rules. These are the rules, and this is known as the production rules. And star symbol is the root node of the parse tree. So we are starting from capital S. That's why this is nothing but the star symbol. This is a non-terminal as well as a star symbol. Now, we have to understand the derivation of the parse tree, derivation of the grammar. So derivation of the grammar can be divided into two different ways, can be derived into two different ways. First of all, LMD, and second of all, RMD. LMD is nothing but the leftmost derivation, and RMD is nothing but the rightmost derivation. So let us understand by one example. Okay, then you will be understanding it very well. So here we have the one example where LMD and RMD is written over the header, and LMD is nothing but the left to right derivation, and RMD is nothing but the right to left derivation, as the first letter of this LMD is suggesting us. So in the compiler design, all names which are already defined in compiler design has some means in order to understand you. Okay, now let us take one rules of grammar. This is the rules of grammar. S derives capital S plus S, small s, capital S minus S, small a, small b, small c. So this is the rules of a grammar. So we have to derive it using LMD, then using RMD. So both are written same. First of all, we have to write the same production rule as same as given, and in the second step we have to write from one thing. So there you can see that there one production S derives into S plus S or S minus S. So S plus S is nothing but a variable or non-terminal which can be derived further on into small a, small b, small c. So we will first of all take the S plus S and would like to derive it. Would want to derive it using the LMD, means left to right. And second of all, we would be taking the S minus S and would try to derive it using RMD, that is from right then to left. So let us start with with the first rules of grammar, that is s derives capital S plus S. So we have written over here s derives S plus S. So as by name it is suggesting that LMD means from left to right. So first of all this capital S must be derived, then this capital S must be derived. So we are deriving first of all this capital S. So we can write instead of this capital S as right over here. Okay, as I am writing it. So we can write capital S derives what? Capital S derives capital S minus S. So as you can see it here, instead of this capital S, we have put capital S minus capital S. And this plus S is written as it is written as it is. So from left to right, we are deriving the capital S, or you can say the non-terminals. That's why this is known as LMD. Now, in the second one, we have to consider which S is at the leftmost, which non-terminal is at the leftmost. So this is the S which is at the leftmost. So first of all, we have to derive this capital S. So we can derive this capital S into either small a, small b, or small c, which are nothing but the terminals which cannot be further derived. So we can take a capital S derives small a. So here it is capital S derives small a. Now since all the left hand side, the left terminals and non-terminals has been derived into non-terminals, that's why the remains are written as it is. See it here, C plus S. Now in the next term we will be deriving the leftmost non-terminals, which is nothing but the capital S. This middle capital S will be derived into small b, and at last the leftmost non-terminal will be this capital S, which will be derived into this small c. So at last we are getting the syntax a minus b plus c. In this way we want to derive the RMD as well. So RMD, we are taking for RMD this middle S minus S production rule, so that we can derive the same syntax as we want. Okay, so let us start with S derives S minus S. So as by name is, it is suggesting that RMD is nothing but starting from right to left. So we would have to derive this rightmost side of the capital S. So first of all, instead of this capital S variable, we are writing capital S plus S, which is nothing but S derives capital S plus S, as you can see it here. So we have written instead of this capital S, S plus S. Now the right hand side, in the rightmost side, which is the variable, this is the variable which is nothing but the capital S. So this capital S will be derived into small c, and this capital S will be derived into small b, and at last the non-terminals, that is variable, will be this rightmost side will be the capital S, which will be replaced by small a. So as you can see it here, that we are getting the same syntax a minus b plus c right over left hand side of the LMD, and right over the right hand side of the RMD. So this is the right hand side and this is the left hand side. So we are getting both syntax as same as before. So this is nothing but S a minus b plus c. So S derives the a minus b plus c. Now as a parser, when a parser will generate the parse tree, he will get confused. Why? Because the same syntax is being derived from the two different ways. First of all, we are taking this first production rule, that is S derives capital S plus capital S, and then second of all, we are deriving the same syntax from the S derives capital S minus small s. That's why the parser will get confused, because in two ways we can derive this a minus b plus c. So parser will get confused. So let us take one real life example. Okay, suppose you have two mobile phone. Okay, and both are of Nokia brand, and both you are given the both mobile at once. Now you will get confused or not when there will be a missed call over right there. So you will be confused from which mobile the ringing is going on, from which mobile the ringing is going on, which mobile should I pick up. Okay, so in that way the parcel will get confused, from which way should I go. Okay, suppose you want to go to school. Okay, you want to go to school, either your college or institute, but there are two different ways to reach your college or institute or school. Now you will get confused from which path you want to go with. Okay, so that's the way the parser will get confused, because we can derive the same syntax using two different ways. Okay, using LMD and using RMD. So this is called nothing but the ambiguity, which is written over here. So we will be studying this ambiguity property of the grammar in the upcoming videos. So till now, hope you have understood what is grammar, what are the four tuples of grammar, STPS, and what are the terminals, non-terminals, what are the starting symbol, what are the production rules, how can we derive the LMD and RMD using the different rules of grammar of the same syntax, A minus B plus C. So I hope you have understood. Thank you.